In this video, let's look at what a jagged array in C# is. A jagged array is similar to a two-dimensional array, but it's just that each row can have different number of columns. So if we take a look at this, the zeroth row has 3 columns, basically the elements 9, 6, 5. The first row, now I'm going with the zero-based index, has 2 columns, 0 and 1. And the second row has 5 columns, 1, 5, 8, 7, 6, and the last row has 1 column, which is 3. And in total, the array has 4 rows. Now, if you compare this to a two-dimensional array, now had we gone with a two-dimensional array, then we would have had to take these many columns in each row, whether or not there were some elements here. So that would actually be a waste of space, given that most of the spaces here are not used at all. So if you know the fact that an integer has about 4 bytes each, so you'll be multiplying with these many empty spaces, so you'll be losing that many bytes. And it might not feel a great deal in when running these applications for small sized array like this, but eventually if you are using this to represent some kind of data like a sparse matrix or the bits of an image, high resolution image, and as and when the array size becomes more and more, there will be more memory consumption, and if you just use two-dimensional arrays, it would be less efficient. So that is the reason why we use jagged array, and the declaration and usage of it is similar to a two-dimensional array, but it differs in certain places. So let's take a look at how the implementation of this would be had I implemented the same array here. Um, it would look similar to this. So in fact, it is the same diagram here, 96501 and 12587 and 3. So here, if you notice, we just have opening closing braces here and 2 of them. So this is how it differs with a two-dimensional array, if you remember. But the declaration of it is very similar to a two-dimensional array. It's just that we have uneven columns here. Now I could have put them in the same row also, but just for the sake of visual clarity, I've just put it in different rows. And if you see how I am looping through this, you will also find a little different. Now, in our previous two-dimensional array analysis, we had taken the specific rows and column lengths. We could have done that here also, but I rather used the built-in property. Now, this is a property. So this is a built-in property which every array in a C hash will have. And we are using this to iterate over this array. So basically this will give me the length, or in fact this will give me the number of rows here, and this will give me the number of columns. If you think of this, it is actually like we are dealing with an array of sorts. So basically each element in the top level array is an array by itself. So if you go by that, we will just get the length of the columns. And then we can print this as usual, just the way we were printing elements in a two-dimensional array. And this I'm using for spacing because I'm using a string interpolation operator. So it just makes it a little more spaced. And this will write an empty line so that we can see the actual elements in 4 different rows. Let's take a look at how the output will be if I run this application. So right now I'll just run this without need to debug it as of now, so as to see the output. So maybe I'll probably just do a clear screen once and then run this. So we do get the same output here, and because of the spacing, this looks even better. Okay. Let us also look into how this would look in debugging mode so that we can visualize this jagged array better. So for that reason, I'll just set a breakpoint here. And as usual, I'll go to the debugging mode here. The moment we hit the breakpoint at line number 9, we should be able to see the local variables, which we have here. Let me minimize this. And here, if you see, right away, we can see that there are 4 rows here. And we have an expansion section here. So let's see what happens when we expand it. So this corresponds here. If you see, the first row has 3 columns and the second one has 2. This next one has 5 and 1. We could have actually created this ourselves. We went ahead and did it this way, assuming that we know the contents of the array already. If we had to dynamically allocate it, maybe by asking from the user, or maybe we were planning to read it from elsewhere, we'll see how we can do that. But for the time being, if I just expand the contents of the first row represented by 0, we do get the 9, 6, and 5. And similarly, the second row represented by 1, we get the elements 0 and 1. And suppose we had to change the last element in the first column, we could have done it, or we can still write a code for it, something like ARR of 0, comma, or not a comma here, actually, 2 separate braces, 0 and 2 is equal to, let's say we wanted to make it 50, so we would assign 50 to this here. Similarly, if we wanted to read that particular element, I would also do something like this. So this is again similar but not same as compared to the two-dimensional arrays, especially the two bracket syntax here does vary. And what if I had to dynamically allocate these? So in order to do that, I'll just stop debugging now and collapse this window, and perhaps temporarily just comment out this piece of code. And I have a new set of code copied. And here, if you see, instead of me hard coding all the values right away, now assuming I'll be reading them later somehow, all I had to know was that I wanted to create an array of 4 rows, a jagged array of 4 rows, but the columns we don't know at this point yet. In fact, even this 4, we could have taken it from the user himself without hard coding it. Now, assuming that we have 4 rows, and then let's say we could have also had other code here, and eventually we decide that in the first row we will have 3 columns. So we would actually do it this way. We would say array of 0 is equal to new int of 3. So this is where we are allocating the space for 3 columns, because remember, we are not doing it with hard-coded values right away. And how would we put the values here? Like we discussed, the first column in the first row would be represented by 0 and 0, the second column with a 0 and 1, so on and so forth. And what about the other rows? This we did it with 965. So for the second row, we represent by jagged array of 1. And remember, we are using only one index here because we are allocating the space. How much or how many? 2. So we allocate 2 here. And in a very similar fashion, instead of 0, 0 and 0 and 1, we do it as 1, 0 and 1, 1 and assign the values 0 and 1 respectively. And we do it for other rows. So using this technique also, we can allocate and assign the elements of a jagged array. So now that we have understood the basics, Let me take off this code because I just want to show how we can actually print the elements in a much more easier way using a more advanced loop or the for each loop. So I'll uncomment these. So we have this normal for loop where we have taken two indices I and j, and we loop through the rows and columns by getting the values using the length property. So we do that once for the rows and we do it again for the columns as well. But if you look at here, we are not really dealing with these indices at all. I mean, all we want to do is iterate over the arrays and print the elements. So much more easier way would be to do this using the for each loop. If you just notice here, this is the temporary variable, which we call it as row. Now this temporary variable is in itself an array. So every individual item in the row is itself an array because you can think of it as an array of array. Whereas once we get hold of a row, we then loop through all the elements in that row, each of which is an integer, right? So just to repeat, the outer loop gets hold of the rows and the inner loop gets hold of the columns. And again, element here is just a temporary name which we give. We could have given it anything. And using a string interpolation operator, I'm spacing it by 3. Perhaps just to see some difference, I'll also space it with 5 and then run this particular file here just to see how the output will be. So the first output we are getting it with the normal for loop, and the second one we are getting with the for each loop. And since we've spaced it better, we can also see the difference of how it is appearing. But this we can see is way more easier to read as well, since it has no indices and manual incrementing and conditional operators. So to conclude, we just saw what a jagged array is, how the elements are represented. We saw another way of dynamically allocating the space for it, and we saw how to iterate over it using the normal for loop and then the more advanced loop or the for each loop.